What is up, plant people? Hey, today is, well, I don't even know what today is. It's a Thursday, I think. That means it's time again for the Planthropology Podcast. Sure, we dive into the lives, careers, and general awesomeness of some very cool plant people and also some very cool plant topics. I'm Vikram Baliga, your host, your humble guide in this journey through the sciences. And today's episode has been intended for release at least like 4 times at this point. If you're listening to this when it comes out, it's late January 2022. Oh my goodness, 2022. Oh, I almost took us back 2 years, and I don't want to go back to there. I do not want to go to there. And I've tried to get this episode out a few times, and it's either been, Christmas and I've been taking a break, or the last couple times I've been sick. I've been sick a lot over the past few weeks. So is my son. So is my wife. I don't have the COVID, which is good, but I've got some other incredibly terrible illness that feels like coughing and sadness. I'm doing better today, so I'm finally recording this. So if I break into a coughing fit halfway through this, well, you'll never know about it because I'll edit it out, but just assume that it happened at some point during this recording. So today is installment number 2 of this year's Tree Talk series. And if you'll remember, I think back in November was when the first one came out, we talked about how trees aren't real, or trees as we think of them are not really a phylogenetic term. It's just a useful categorization term that we throw around, and it is useful and it is meaningful, but they don't exist in the way that we typically think they do. So today we're going to talk about the tree's origin story. Now I know over the past 10, 15 years, we've watched a lot of origin stories, from the Hulk a couple of times to the Fantastic Four a couple of times, and Captain America and so many others. And we've seen all the origin stories. And today you're going to get another one. So we're going to talk about the evolutionary history of trees, and then we're going to talk a little bit about the life cycle of a tree. And we'll get later in this series more in detail on some of the physiology and botany that goes into tree development and growth. But I wanted to give you an overview of what a tree do and how it do over the time that it does. None of that made any sense, and I'm leaving it in. So without too much more rambling, hey, let's play some music, let's hang out together, and let's talk about Tree Talk. Episode 2, Just Another Origin Story. Okie dokie. You still there? Hey, I'm glad you stuck with me. We've made it this far. Why not stick with me the rest of the time? So this is probably not going to be an especially long episode, but I wanted to go over some of the brief history of trees, because I think as we continue through this saga, we're going to... Saga? Is that how... Saga? Saga? Someone tell me how to pronounce that word. I've said this before, but I'm from Texas. I barely speak English, so you're going to have to forgive me just a little bit. But it is important to know where the things we study and where the things we talk about come from, even though it is sometimes frustrating to watch another origin story over and over and over again. And how many people really need this play Spider-Man? I mean, really? I could play Spider-Man. Nobody's going to ask me to do that, but I would do it. I'm ready for the call. I'll have to do some sit-ups or something, but it's okay. So as we talk about trees and as we go through this series, I think it's going to be imperative that we understand some of the basic functions and environmental conditions that influence the growth of trees. And we've seen this throughout time, that trees were pushed in one direction or the other by their environment. And really, that's true of everything, right? When we talk about the evolutionary history of an organism, it is based on competition. So we'll talk about why trees today, we'll talk about why trees got some of the forms that they did, why they developed in the way they did at some of the times that they did. And I think knowing some of the environmental challenges they faced as they developed and that they still face today is really important in understanding the way they present themselves. And that's true, again, for all organisms. The reason that things are driven in an evolutionary direction in which they are is really because of environmental limitations, environmental pressures, selection pressure, if you will, and competition. All of these different things select for certain traits in a plant or an animal or in a fungi or whatever, and are sort of deleterious or harmful to others. So we first start to see some of the earliest trees sometime in the Carboniferous period. So this is thought to be somewhere around 400 million years ago. That's quite some time, and it is a time frame that I think is hard to consider and comprehend. Our lives in the grand scheme of the universe are so short. We're here for such a short time that when we hear numbers like this, it's sometimes easy to think, well, it doesn't mean anything after a certain point, right? These numbers don't matter. But they do in the fact that it provides some context with how long it takes sometimes for selection to happen. And there have been times in history when selection happened very fast, maybe with cataclysmic events, and organisms that could survive said cataclysmic events were aggressively selected for, right? An asteroid, a giant fire, a volcano, whatever. It could be global, could be in a specific ecosystem, but that is aggressive selection pressure, right? And the things that are left have to either figure out how to survive or not. And it's estimated that probably 99% of the species that have ever existed on this planet have come and gone, which is sobering in a lot of ways, but it's so fascinating to think about that life finds a way. Some days I wish I was more like Jeff Goldblum. It's not a lot of days, but every now and then. Okay, getting back to it. So there were other plants before trees, right? Some proto-plants, some things that were the evolutionary forebearers to the plants we think of today. So around this time in the Carboniferous period, again, around 400 million years ago, the first tree-like plants started to appear. Now, these were probably more like ferns or lycophytes or horsetails, larger plants that didn't have seeds, didn't have some of the other secondary structures we tend to think of as in modern plants, but they were different in a way that they were the first to have vascular systems. Okay? It's interesting to think about that most of the plants before this time were things like mosses, liverworts, things that grew close to the ground in a moist environment. All right. That is important to understand in some ways because there's a level of complexity necessary in a plant to move water and nutrients from close to the ground up to taller parts of the plant. But enter selection pressure. And I want you to think about as we go through this what pressures may have been faced by bryophytes, early other plants that were really close to the ground. The animals at the time were also pretty close to the ground. So if maybe they were able to easily graze on those plants died and they weren't able to reproduce and make more plants. But maybe the taller ones that had leaves that were or leaf-like structures that were at a higher elevation tended to survive and were able to reproduce. And at some point, we start to get taller animals that can reach those taller plants. And so we select again for the tallest plants. And then maybe having a succulent sort of, or that word is always strange in context, some context that it's used. Anyway, it always feels weird for me to say it, but succulent stems or more herbaceous, like fleshy, squishy stems, they're easy for predation, right? Things can munch on them pretty easily. So we start to select for plants that have a woody, harder stem. And over time, and again, we're talking, evolutionary, geologic time, we start to see that we have developed plants that are very tall, that have a good defensive structure like wood and lignin and bark, things that are not necessarily palatable or useful to an herbivore that it's trying to eat it, and it moves its leaves up taller. And so over time, we've started to select for both animals that can access plants like this, and then plants themselves that can get out of the reach of their predators. And we see throughout time that plants have developed a lot of different defense strategies and things to combat herbivory. And just like animals have come up with defensive measures, plants have as well. So we go through time, and about 380 million years ago, we start to see the evidence of the first seeded plants. Now, these were simple seeds. They were not necessarily what we think of today. They were very, very, very simple, but they were genetic material that came from a parent plant with some sort of genetic diversity that would move on. 360 million years ago, we start to see gymnosperms, which are like conifers. We think of a gymnosperm as like a pine tree or a ginkgo biloba. We'll talk about our friend ginkgo here in just a minute. But in those, they have some kind of a cone. The cones would open, the seeds would drop out. They'd be eaten by an animal and move somewhere, or washed away in water and germinate somewhere else. But they don't have that protective fruit covering on them like our fruiting plants like an apple tree or whatever would today. About 200 million years ago, we have evidence of the first ginkgo trees, which were some of the first broadleaf trees. Before that, the leaves were either very fern-like or very needle-like to account for weird climatic conditions, different pressures put upon them. Again, when we talk about evolutionary history, we're talking about competition and selection pressure, okay? 150 million years ago, we start to see pine trees. 125, angiosperms began to evolve, and we started to see flowers on the planet. This was a warm, sort of advantageous time for plants on the planet. And so plants could spend the resources necessary to develop new ways to disperse seed. And I talk about this like the plant wanted to do something. And in certain ways, and we'll talk about this throughout this series, that, okay, yeah, plants don't think and reason like we do, but they are trying to survive. So there is a imperative that drives them in certain directions. So when I say a plant wanted to do that, okay, it wasn't like, I want to get a taco, and it went to do the thing, but there were advantages for it growing in certain directions. Around 67 million years ago, we probably start to see maple trees, 56 million, oak trees. And from there, we're getting, now again, I'm saying words like millions of years. And so we're not into like, hey, there's a bus that drove under that tree at this time, but we're getting closer and closer to our modern species, which have diversified and changed and adapted over time. And we see today incredible biodiversity in trees that serve a lot of purposes, from different ecosystems to different habitats. They play an important role pretty much anywhere they are. And so over time, they have developed a lot of things, right? From flowers and fruits and seeds to interesting dispersal methods. So a couple of those that I wanted to talk about now. We'll talk about fruits and seeds later in another episode, but there's some really interesting ones. You know, the ones we think about most is like, okay, this tree grows apple. Animal eat apple. Animal poop apple seed somewhere else. Apple seed grow, make more apple tree. Next animal does the same thing, right? It goes on and on. It is a continuing process. But then let's talk about maple trees, that they don't produce the kind of fruit that many animals want. Now seed-eating animals like squirrels or mice or whatever will eat them, but those animals tend to cause a lot of damage to the seed as they eat it. And their digestive system digests the seed well. They have very sharp, crunchy little teeth, so they can cause problems. So in order to move those seeds far away from the parent plant, trees like elms, maples, a couple others have developed something called a samara, which is like a little helicopter. And the seed with this little fruit structure and these little wings fall off the tree. They spiral. I cannot say this word. I'm going to leave that in because this is what happens when I record this podcast. They spiral. I did it wrong again. Spiral they spiral around and around like a little helicopter, and they fly away from the base of the plant. Some trees, like there's one tree called the dynamite tree, and I'm going to do an episode at some point on weird angry trees. There's a few. But this dynamite tree has a big fruit, looks kind of like a pumpkin, like a medium-sized pumpkin that literally explodes, right? It drops off the plant. It is sort of packed into under tension. And when it hits the ground, it can launch seeds out at like 150 miles per hour. It literally blows up. It blow up. And through that, it disperses the seed. It has really, and maybe any animal that's like, hey, falling pumpkin, I'm going to eat this, is like, oh no, a grenade. Anyway, whatever. So over time, plants have developed a lot of really fascinating and really incredible survival mechanisms. And trees are one plant adaptation that has let them survive herbivory and forest fires and things like hurricanes and weather and all of the many pressures, both biotic and abiotic, which are put upon them by this crazy planet, right? So they're really fascinating organisms, both in modern history and from an evolutionary standpoint. So that's a very, very quick overview over the history of trees. We'll talk about a couple of other things as we go through this. I'll probably pull in some other tidbits in future episodes, but I just wanted to give you a quick primer on when and where and how they started to show up. So we're going to take a quick break. I'm going to play some jangly elevator music at you. I'm going to tell you a few things about the podcast. You might hear a trailer, you might not. Surprises. There's always another surprise in life. Life is all about discovery and surprises. And then we'll be back and we're going to talk about the life cycle of a tree and where trees come from today. Well, hey there. Welcome to the Min Roll. I just love seeing you here. It's such a good time. We get to chat, just you and me. We don't do this enough, my friend. We don't just get to talk anymore. How's your mom? How are the kids? How's the wife? Husband? Doing well? Great. I'm so glad to hear it. Hey, thanks so much for listening to this episode and thanks so much as always for being a part of this. I'm glad you've made it this far. You like talking about trees? I sure do. I'm enjoying this series. We've got a lot more coming up in this series. But for now, if you want to connect with Planthropology, there are a lot of ways to do it. You can find us on Instagram, Twitter, Facebook. Search for Planthropology. It is anthropology with a PL slapped on the front. Look for that green background with the bristlecone pine, and that'll be me. You can also join the Planthropology's Cool Plant People Facebook group on, Facebook. We have lots of fun in there. There's memes and discussion and all kinds of goodness. You'll find out about new episodes, bonus content, and really whatever else I can think of to put on there. It is something that you want to be part of. If you want to support the show, there's a couple ways to do it. You could head over to buymeacoffee.com/planthropology and buy me a coffee. You can do a one-time donation if you want to. You can do a monthly donation. I'll have some extras and stuff that go on there at some point, but it is totally optional. It's if you want to help out, you sure can. I will most likely literally spend it on coffee. It's the truth. If you would be so kind as to go leave a rating and review somewhere, I would really appreciate that too, whether it's on Apple, Podchaser, CastBox. Now you can leave a rating on Spotify. So if you're listening to this right now on that there Spotify machine, go to the description and give me a 5-star rating if you don't mind. It's my favorite size of rating with 5 stars. It would mean a lot to me. But for now, I just appreciate you being here. We've got lots more great Planthropology coming up this year. I'm going to get back on a regular schedule. This show will hopefully come out weekly throughout the year 2022. Probably, hopefully, maybe. But at any rate, I've got great interviews, great content, lots of solo stuff, and I think you're really going to enjoy this. It's changed over the years, and it's evolved, and I think you are going to love the direction we're heading. But let me know if you do. You can send me an email at planthropologypod@gmail.com, and I'd love to hear from you there as well. But before we get back to talking about where trees come from, check out this trailer from another great show from the Podfix Network, Podcast 42, in 5, 4, 3, 2, 1.
Four podcasters who are lost in an interdimensional anomaly travel from planet to planet, each based on their own pop culture reference in search of home. Along the way they might learn something, but probably not.
She got too close and, whammo, it sucked the spaceship right in.
Oh no! Wait a minute. Was it whammo or more like cling-a-clunk?
It was definitely whammo.
And Mark.
Captain! They're all dead!
Oh my. Not now! You need to manage our fighter, and I need to referee. And I guess, Chris, you are going to have to call this thing since the rest of us are doing actual work, and you're watching AI porn.
Yeah, don't knock it until you tried it. Man, the gears on that one. Whoa. You should really see this. Someone's about to get oiled.
Quaker State or Pennzoil?
Don't help him. What difference does it make?
Viscosity.
I don't know what that means.
It's really just a preference. JL, why don't you book an appointment with me for Tuesday? Let's say at 3? You have been terribly angry lately.
I would say more like terribly snarky.
I'm not riding a horse, nor am I letting you analyze me.
See? Anger issues!
It's podcast 42.
Okay, we're back. So this last segment will be pretty short. I think I promised you that before, and it's already less short than I intended, but that is how my life goes. I am long-winded and vociferous, and yeah, my students hate it. It's great, whatever. So where do trees come from today? How does that whole process work? So trees come from a lot of places, and the easiest place to think about, or the place we kind of think about most commonly, is probably from a seed, right? Trees, plants germinate from some kind of a seed. And it's this big, complicated process where you have male and female plants that have genetic material that they share. And from that, you get a seed, and genetic diversity arises. And it turns out plants don't really do it how animals do. That maybe sounded dirtier than I intended it to, but it's okay. It's really a complicated process. And we have, when we look at plants and when we look at trees specifically here, trees that are distinctly male, distinctly female. Some plants are male at some parts of the day, female at different parts of the day. They can have both male and female flowers on the same plant. They can have male and female parts in the same flower, or any combination thereof. So getting to a seed can be an incredibly difficult and incredibly complicated process in plants. And that's okay. It's part of this whole game, and it leads to genetic diversity, right? We get the recombination of genes, and we get all of these different things that lead to advances in a species. You get hybrid vigor with subsequent generations, where the progeny tends to be better in some way, or a good combination and a stronger combination of both parents. You get beneficial traits that come from both the male and female side of the plant. And some of these interactions, some of these pollination cycles are incredibly complicated. And I want to talk about one today, and that's avocados. So avocados are expensive for a lot of reasons. A lot of them are geopolitical. A lot of the land where avocados are grown, especially in South America, are controlled by cartels. And there's a lot of pressure put on the farmers, on the exports and things like that. And so there's a lot of politics and crime that goes into avocado prices. One thing, though, that contributes to it as well is that they're incredibly hard to pollinate. Now, in nature just kind of figures it out, right? There has been a evolutionary coevolution between different varieties or species of avocado that lead to this combination. But the plant is trying to make sure that it does not get offspring that are too genetically similar to the parent. Genetic diversity, especially in a species that can be hard to pollinate properly and fertilize properly, is really important. You want to give the offspring the best chance of survival by taking beneficial traits from both parents. So a lot of avocados have both male and female flowers on the same plant, but those flowers are separate. And a lot of times the male flowers will be open in the morning and the female flowers will be open in the afternoon, or vice versa. And it turns out we get different types of these trees that live close together. And so in type A, the male flowers may be open in the morning, and on type B, the female flowers might be open in the morning, and you get cross-pollination that way. Or in some cases, it's the other way around. And what that ensures in the plant is that when it pollinates, you're getting successful cross-pollination, where those flowers are what we might call incomplete or imperfect flowers. So they don't have all of the parts in them. They're either male or female, or they're missing petals, or the leaf-like structures under the petals that are called sepals, and or something or the other. They're not complete flowers. And because of that, it allows for greater genetic diversity because different varieties or different species have to cross-pollinate. Compare that with, say, a peach tree. A peach tree is self-fertile. So a peach flower has both the male and female reproductive parts in the same plant, and that tree can pollinate itself. And it does just fine. But what we see is that when we get cross-pollination in peach trees or some other varieties, we get enhanced fruit set, fruit quality, all of those things. So pollination and cross-pollination and genetic diversity is still a very, very good thing in these species. Even if they're self-fertile, even if the flowers are complete, perfect flowers that can self-pollinate, it can still be an issue. So after that, we get a seed. It is either developed in a cone, and conifers, I'll say, gymnosperms do things a little bit differently. If you live in Central Texas or somewhere that cedar trees exist right now, I'm so sorry, because it's pollen season. And if you've ever seen a video, you should Google a video, and maybe I'll put one in the show notes, of pollen season in Austin, Texas. And it looks like either there's dust in the air or there's fog in the air. No, my friends, that is pollen from male cedar trees. Because most gymnosperms, conifers, are wind pollinated. So they have these really, really light pollen grains that are blown around from the male cone, the pollen cone, by the wind, and then they'll land on a female cone and fertilize it. You get development of the seeds inside that cone. It opens up, they drop out, etc. So in a gymnosperm, that's what the seed looks like. In an angiosperm, or a flowering plant, we usually see some kind of a fruit. Now, these look different ways. Again, like I mentioned earlier, you may have a samara like on a maple tree, or you might have an apple. And these different structures cause the seeds to be dispersed in different ways, either by the wind or by water or by an animal or a combination thereof. And it all just depends on the adaptations that plant had to go through to be able to reproduce and live effectively in whatever climate, whatever ecosystem in which it involved. And it's various and it changes, and you'll see further adaptations if that tree is moved to a different area. But eventually we get a seed, that seed germinates, and it grows into a tree. And I think it's such an amazing thing that a tiny little seed has all the DNA, all the instructions and information, and just brilliant design to turn into an incredibly large tree. So a seed from a giant sequoia is really quite small, considerably smaller than a dime, maybe smaller than the eraser of your pencil. And over time, it develops into these trees that are hundreds of feet tall, weigh thousands of tons, and that are big enough that you could drive a couple of cars through the trunk. And it all comes from the genetic material stored in this incredibly ingenious little thing, this tiny little thing that we don't think about. We see seeds all the time. We spit our apple seeds in the garbage or whatever, but it is the stuff of life that is encased in this hard little seed. And it's just incredible to me. It boggles my mind that something so great and so huge can come from something so small and simple. And it's really a cool picture of the things that come out of life in general and how life develops. Another way that plants and some trees develop and reproduce is asexually, or through clonal propagation. We see this in some particular trees. Some oaks will do it. If you've ever had a live oak in your yard, you've noticed that there's tons and tons of tiny little baby live oak trees that pop up around the base of it. That's not coming from seed or acorns usually. That is coming from roots, and it's coming up from that root and developing. And then over time, the ones closer to the trunk of the parent plant will sort of die out because they don't get the resources. But the ones that can get enough sunlight, enough water, because they're outside of the drip line of that parent plant, will develop and do the same thing over and over. Now, do live oaks spread through acorns? Yes, of course they do. But where they grow is oftentimes in prairies, where they can sprawl and spread out and take over lots of area very quickly. Willows do something similar to this. A lot of willow trees grow on riverbanks and in very wet areas. So they'll put out this long branch that droops down and hits the soil, or a branch will break off and hit this wet soil or stick in the mud or whatever, and they propagate very readily. So wherever a node, which is a point of leaf attachment or stem attachment or anything that's attached to a stem, hits this wet, nutrient-rich, moist environment, it'll start to grow roots. Because, y'all, every plant cell has the genetic potential and all the genetic material and information necessary to be any plant cell. So those cells where they're underwater now, they're underground, there's no light, they're more influenced by gravity in different ways, there's chemical signaling. It tells those cells, okay, I don't need to be branch cells anymore or leaf cells anymore. I need to be roots, because the rest of the plant needs roots. And they become roots, and they start to differentiate or re-differentiate into roots. And we have this grand, incredible progression of life that happens in trees all around us all the time. And we don't see it because, they're just street trees. They're just forest trees. And we miss out on this incredible wonder that is the process of biology that's happening all around us. Nature's incredible, folks. Absolutely incredible. So that was a brief overview of both the evolutionary and biological life cycle today of a tree. Now, is there a lot more to learn? Absolutely, yes. And we'll cover a lot more of that in the series. But I wanted to give you an overview and maybe just a primer of where our woody friends come from as we progress through this series. Y'all, thanks so much for listening. You know that it means the world to me that you take part in this. Thanks so much to the Texas Tech Department of Plant and Soil Science for the constant support, for even letting me do this wild podcast thing. It means the world to me as well. I love you folks. I hope that you are out there being safe. Things are wild right now, but we can get through it. We will get through it. Keep being kind. If you have not been kind, maybe give that a shot. Start doing the thing. And I hope that you will keep being very cool plant people. And I hope that you'll come back next week for more Planthropology. I love you folks. You take care. We'll talk soon.